Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 26 of the November Daily LeetCode Challenge, and I'm very happy to announce that this is the first day of the graph questions. Okay, there are just 4 days remaining for November Daily LeetCode Challenge, and now the graph series is starting. Till now we were having questions on matrix. Okay, for the last 5 days, 5 6 days, we are having questions on matrix, and today for the first day we are having a graph. So this is the first time in November Daily LeetCode Challenge that a question on graph is coming. Okay, this is on the very easier side. If you are bit aware of what the graph algorithms are, this will be on the easier side for you. Okay, you'll see this question, and yeah, it's very easy solution. Within like 5 7 lines you can write it. So let's quickly begin what it is. So it's the question is find chapter 2. So don't worry if you have not done the first part of this question, that doesn't matter because first part was not there in the November Daily Code Challenge. But anyway, this question itself is so simple that you don't need to see the previous part. As simple as that. Let's see now. So basically, if you see, you are given something like this. Okay, there are only two inputs in this. First input is the number of, see the n. N tells me like how many edges are there. Okay, sorry, how many nodes are there. That is, if n is 3, that means there are three nodes starting from 0 till 2, 0 1 and 2. Okay, and this edges tells me what are the edges. That is, there is an edge from 0 to 1. Okay, there is an edge from 1 and 2, 1 to 2. Okay, so these are something like that. Remember, these all have directions. Okay, these are not bi-directional, these have a direction. Okay, proper direction. For example, this is from 0 towards 1. Okay, this is from 1 towards 2. Okay, and so on. Okay, and like that. So what they are trying to say is, when I write 0 and 1, see, the idea is very simple here. There are, you can say, like three teams. Okay, in this case n equal to 3, that means there are three teams. Okay, team 0, team 1 and team 2, right? When I say 0 comma 1, 0 comma 1 is as, that is, there is a arrow from 0 towards 1. That means team 0 is better than team 1. Okay, that is the meaning of that. Team 0 is better than team 1, and the meaning of this is team 1 is better than team 2. Okay, so at last you will have to tell me which team is better. Okay, so after seeing all these things, all the comparisons, okay, so at last you will have to predict which team is better. Okay, only if there is a single team which is unique and better, you have to return that. If there are more than one teams which are, they have a possibility of winning, that are, see, you will get to know the cases, but just I'm telling you, heads up. Okay, because in the actual question, these are just heads up. Only if there is a one final team which is, better than all other teams, that has to be the answer. If there is not, that is not possible, that is, there are more than one teams which can be, superior to compared to others, in that case we have written -1 as the answer. Okay, we'll see that, but let's just to make you understand before the going to the question, I just show you that. Okay, the question is slightly bigger, but it's very simple actually. There are n teams numbered from 0 to n-1 in a tournament. Each team is also a node in a DAG. Okay, what is DAG? DAG is basically directed acyclic graph. Okay, so if you see here, they've given it like a graph. So these are like acyclic graph. That is, it cannot form a cycle. Why it cannot form a cycle? Because of the constraints they have given. Okay, if you see the constraints, we'll get to know why it cannot form a cycle. So yeah, that is something they're given. Okay, DAG. So you are given an integer n and a zero index 2D integer array edges of length m representing the DAG. Okay, where edges of I is equal to ui comma vi indicates that there is a directed edge from ui to team vi in the graph. So what it means is that, yeah, so when I say ui comma vi, so see, there will be edge from the first number in this particular, see, this whole is element, right? If you see, it's a 2D graph. So each is array, like, so each element is array. So in this single element, what you have to do, there is edge from ui to vi. Okay, that is what you have to understand. The directed graph from edge a to b in the graph means that a is stronger than b and team b is weaker than a. Okay, so this part is the central part of this question. If you understand this, you have to, see, simply you can skip the everything else basically. Okay, all these things are, just for those who are beginners. Okay, if you are a pro, then you don't have to read all these things. Okay, you already know what is a tag, right? So this is the only part that you have to read. Okay, so there is array from a to e, that means if there is array from a towards b, that means a is superior than b. Okay, team a is superior than team b. Team a will be the champion of the tournament if there is no team b that is stronger than team a. Okay, very simple, they have given. Okay, return the team that will be champion of the tournament if there is a unique champion, otherwise return manual. Remember, there has to be only one champion. Okay, if there is a possibility that there can be two champions, then you have to return -1. Please make this thing very clear. These are some of the edge cases that will come. Okay, the question looks simple, but the thing that I've highlighted on the screen now will form the edge case. Okay, I'm damn sure if you do not consider this, if you do not understand this point, you will write proper solutions, but still, in one test case it will be failing. I have captured those test cases also, and I will be showing them you in a part of the trial. So just be careful. So the funda is very simple here. What is the thing is, see, for example, see, certain things can be compared. Okay, so like this it is mentioned. If you see the second example, yeah, in this, if you see what is happening, 1 is greater than 3 and 2. Okay, team 1 is better than 3 and team 2. So only team 0 is better than team 2, but there is no statistics with us to understand among 0 and 1 which is better. Okay, do you agree with me in that? So we do not have a record or a particular certificate which tells us like which is better, team 0 is better or team 1 is better. So for that reason we cannot say like which is the better team among them. Okay, so there are two possibilities. Okay, either team 0 or team 1. So we cannot zero down upon one number. Okay, so for that reason we have to return -1 in this case. Okay, that's what I'm trying to highlight you from last 4 5 seconds. So this is the one. Okay, so return the team that will be champion in the tournament if there is a unique team. Okay, only if the team is unique will have to return that. If the team is not unique, there is some discrepancy that some other team can also be the champion. There is no record for which will be the champion. If there are, see, in this case there is no record among 0 and 1 who is going to win. Okay, so for that reason this is like ambiguous thing, so we cannot declare one as the winner, right? So in that case we have to return -1. Okay, this is the important part. Okay, you can go through the notes. Okay, these are just for beginners. I will say these are not something important to solve this question again. Okay, coming to example 1, you can clearly see there is edge from 0 to 1 and then 1 from 2. Okay, 1 to 2. So if you see the basically this point of constraints, so what they're trying to say is if there is a node from that is edge from A to B and edge from B to C, okay, then A is also greater than C, it is also better than C. Okay, that's what they're trying to say. You can go through these cases. N is very small in this case, so you can go through the constraint. I'm not going them because it's not important in this case. It's very small, so I'm not even highlighting this point. Okay, you can go through it if you are not familiar with this concept. Okay, but I don't have to show you these things because the question is not related to that. So you can clearly see there is from 0 to 1 and 1 to 2. That means 0 is better than all of them. Okay, 1 and 2 and n is 3 obviously. Okay, in that case the answer will be 0. In example 2 I've already shown you that say n is 4, so 0 till 3 these are the nodes, and between 0 and 1 we don't have any record to show us which will be better team. So the answer is ambiguous. We have to return -1. Okay, so let us quickly go through some of the cases. Okay, and okay, before that let me show the solution. Yeah. So like I'm going to use the sets. Okay. See, there are multiple things that you can do because n is very small. Okay. Just understand one thing. This is the n. Okay. This is the n and the edges. Okay. I am calling the length of the edges as m. Okay. You can just call it like that because to discuss the time complexity, we'll have to do it in that way. Okay. N is already given. M is not mentioned, but the length of the edge is going to be m. Okay. Just think of it in that way. Since n is very small. Okay. If you see in here, n is around 100. So what you can do is you can just I'm telling the approaches and then I will start my approach. Okay. See, first thing you can do is you can create area of 100 or whatever is n. Okay, what is the n value, you can create a area of that length. Okay, and you can what you can do is you have to store the in order. What is the in order basically is that, see, there are multiple ways I'm telling you. Like, if you find it useful, you can listen, but otherwise you can skip. Okay, because this thing will make sense only if you have solved this question sometimes before you have tried. Okay, if you have not tried, it doesn't make sense to agree with that. So you can make a in order array of length n. Okay, in that you can have boolean values. Okay, what is the boolean value is going to tell me? Boolean value is going to tell me whether this node, that is, it is being pointed by some other node or not. Okay, for example, if I talk about 1, so 1 is being pointed by some other number. Okay, so 1 cannot be the answer. So what I will do is I will the value of that will be false. Okay, as simple as that. You have to create an order array of n values, and in the index 1, okay, see, index 1 will represent the node 1, right? In place of that, what you have to fill false. False will tell me that this node is being pointed by some other node, so it cannot be the answer. Similarly for 2, you have to again fill false. So then I will go through them and see which is not false, that can be the answer. Okay, if there is only one value which is true, then that will be the answer. Okay, so remember one thing, we have to initialize the array with truths first. Okay, so that is something that you can do, that will again take off and space complexity, and you can get the answers. Okay, that is one thing, but I want to show a different approach because these things you will not get. Okay, so I just want to do something different, that's why I'm showing you this. Okay, what I already explained, that is there in many places, you can take that also, but I want to show something different. Okay, so what I'm taking, see, winners is going to be one among them. Do you agree with me? So what I'm going to take, I'm okay, let me zoom in further. Yeah, so I'm going to take the set from 0 to n minus 1. Okay, I'm going to take the set of all of them as my winner set. Okay, as simple as that. Then I'm going to call a loser set. Okay, initially it will be 0. What I'm going to do next, then I'm going through all the edges. Okay, that is all the I comma j's in the edges. Okay, whichever all the j's will be losers. Do you agree with me? So they should be added to loser set. Okay, I'm adding all the j's to loser, as simple as that, right? Finally, I am doing answer is equal to winner minus loser. See, winner is all of them are winner. Okay, that is all the nodes are part of winner. Which nodes are part of loser? Which are being pointed to by some other node. They are part of loser set. Okay, then what I'm doing a set difference of winner minus loser. Remember, this is not a simple subtraction. I'm not doing 4 minus 2 or something like that. This is set subtraction. Remember, both winner and loser are sets. So this is a set subtraction. Okay, so if you're not aware what are sets, these are actually, I guess in the class 10th CBSE, these concepts were there. What are set difference? All those things were there. So this is something similar to that. Okay, this is a set subtraction. So what will happen? happen? All the nodes that are present in loser will be removed from winner, okay, and then winner will be retained, okay. See, the nodes present in loser will be removed from winner, and then the answer will be shown, okay. This is going to be my answer. So answer will have basically those nodes that could be winners, okay. Then what I'm taking the length of the answers, okay, answer length. Then I'm checking whether answer is greater than 1, okay. If it is greater than 1, that means there can, for example, in the example 2 that we saw, right, in example 2 there are 0 and 1, so in that case the answer length will be 2, because there are two numbers which there is two teams which can be possible winners. So in that case I've written -1 because we don't have a clear idea of which team is going to be the winner, okay. There is some ambiguity, we don't have clear picture of which team is going to win, okay, because there's no direct comparison between them, okay. There's no direct match happened between them, so we cannot predict the winner, okay. So because of the statement, okay, because there is no unique champion in that case, we have written -1, okay, something like that. Otherwise, if this condition is not true, that means there will be only one value left in my answer, and I have to return that. One more thing that I want to show is that, see the constraint of n is starting from 1. Remember that n is not starting from 0. The what I want to show is that minimum answer will have at least one element. It can never have zero elements. Remember that it can never have zero elements, because remember it's a acyclic graph, and number of n is going to be a minimum of 1, okay. So answer will never be 0, okay. It will have at least one element. That's why I'm checking only this condition. If answer is greater than 1, I'm not checking whether answer is equal to 0, the answer length is equal to 0. That part I'm simply skipping, because that is not possible at all, okay. So the idea is, if this code is not executed, that means answer will have only one element, and that is being popped out and returned in the final way, okay. So let me quickly run this and show you. We will discuss some of the edge cases also. So yeah, starting with the example 1, okay, let me zoom in again. Yeah, let us go to example 1. Yeah, so n is 3 here, and okay, these are the edges. So the answer is this, okay. Whatever is the answer that I'm printing, okay, these are the answer nodes. In this case we have only single answer, okay. So we are writing the same as the answer node, okay. Remember this will print all the possible answer, then we are popping out and we return the answer, okay. Here the answer is going to be 0. Next, case 2. In this, if you see, there are two nodes which could be possible answers, okay. If you see example 2, there are two nodes which are possible answers. For that reason we are returning -1, okay. Next, coming to edge case 3. Case 3, I guess it will not be there for you, okay. This is something that I've additionally added to test the solutions, okay. Basically, yeah, in the when you segment, okay, this, you can get these cases as well, but at least I've added on my own, okay. In case of n equal to 1, okay, the edges is empty. Try to understand when n is equal to 1, n equal to 1, that means only one node is there, which is that node. It is 0, okay. It is 0. So edges is empty, okay. So there is only one node which could do. So I will trace this out, okay. Let's trace the solution first. Here edges is empty, so can you quickly tell me what and all will happen? Okay, just a second. Yeah, let me bring on the code and we will discuss this part, okay. In this case what is happening is the edges is empty, so this part will not be executed at all, okay. So what will happen, this set will be empty, and in this set there will be only one element, okay, because n is 1, right. So only in the winner, that is will only one node which will be 0. So winner minus loser will basically it's not even happening, because loser is empty and winner has only one node, so that will be written, and that is going to be the answer, okay. So that is what it is. So only one node is present, and that will be written, okay, as it is. Remember that there is no competition happening, nothing. There is single node, and that will be declared as the winner, okay. Case 4 is very important. Please pay attention, because this again similar to example 2. N equal to 2, and there is no, see, n equal to 2, that is means there are two nodes 0 and 1. There is no competition happening. There is no record of which team is going to win over which team, okay. So we cannot determine among 0 and 1 which is going to be the superior team. For that reason, both of them could be the superior team. There is no unique answer, that's why I have written -1. So this was one of the edge case, okay. Case 3 and case 4 are some of the edge cases. Maybe you can include them in your solution, you can test that out, okay. So in this case I've shown you two approaches, okay. Remember, these things are simple, that's why I'm not again coding and showing you the Java solution, but these things are very simple. If you want, you can do it, okay. My aim is to teach you the algorithm, to teach you the thought process. With If you are comfortable in Java, you can try to code it in Java. Only thing is, you'll have to implement this in the Java, okay. That is the only challenge here, okay. Other than that, everything is going to be same in Java and Python, right. That is the only thing, right. I've basically discussed two solutions. First solution is mine itself. The other solution is you can create array, because n is very small in this case. So you can create array, and because n is almost 100 or less than 100, just create array whose value will be true initially, and then whichever okay, nodes are not possible to be answers. That is, in this case, there is a node from 0 to 1, okay. So you have to go to the index 1 and you have to make it false. Similarly, you have to go to index 2 and make it false, because these nodes cannot be answers, because there is something superior to it, okay. So just make them false, and then again go through the array, find which nodes are having the value true, that is in order value true, and those nodes, if it is more than 1, you have to return -1. If it is 1, then you have to return that value, that index, okay. That is the answer idea, basically. If you talk about the space and time complexity of this, If you see here, see, I again mentioned like n is given and the length of edge is going to be m. Okay, so in this case, if you see it, for this thing, it will take O of n. Okay, similarly for this thing, it will take O of m. Okay, yeah, set difference, I am assuming it will be constant because see, at most, see, try to understand, it's just 100, right? Just 100 elements at max will be there in these things. Okay, so yeah, yeah, it should be constant time. Okay, as simple as that, or very minimal time. So I'm not including this in the time complexity. So yeah, that is it. And yeah, I'm just doing a pop, which should be constant time. So it will be O of m plus n. Okay, the time constant will be O of m plus n. Okay, where m is the length of the edges. Coming to space complexity, see, in the worst case, what will happen? See, winner already has an elements, loser will have around n minus 1 elements in the worst case. Okay, around n minus 1 elements. So yeah, again, in the worst case, what will happen? It will be around O of n. Okay, remember, there is no m in the space complexity because m is the number of edges. It will not be part of the space complexity. Only n will be part of the space complexity. Edge will come only in case of time complexity. Okay, the length of edge, that is m, will come only in case of time complexity. So that was all. I can give the solution in the comment section. Let me know your thoughts on the same. And this was the beginning of the long journey for graphs. Let's see how long it goes. So yeah, that was the day one for Java. So see you tomorrow. And if you like my words, please subscribe to my channel. It really gives a lot of motivation to continue further. Thanks a lot.